When you first power the machine up, you'll be brought to this screen, which the title of the screen is up here. It's automatic mode. You would navigate to that screen from any other by hitting the auto button down at the bottom. When you first power the machine up, you'll have a ready light. That ready light tells you that the drive that powers the rotation motor has no faults and is operational. In order to start any sequence though, we first have to home the machine, and we can do that simply by hitting that button. It cycles through and puts all the pneumatics back in their original positions, and also sets the home position for rotation on initial startup. We now have both the home and ready light lit, and we could start a sequence from here. Our next screen is manual, similar format, only we have a few more options. Those options are here on the right hand side. The first one being torch lift, which as we cycle this button, torch up, torch down, it will raise and lower the MIG torches. We also have a button for support lift, and that will raise and lower the support lift for the handle. We do also have a tailstock in and out, and that will also provide us with that same functionality. The lights on the left hand side of these buttons indicate what position they are in. The tailstock has a proc switch, and unless that proc switch is met, it will not read in the ready state. Our next screen is control settings. This screen is password protected. Currently, the password is 1212. From this screen, we could do touchscreen calibration, which is already done and should not need to be done on a regular basis. We can reset the home position so that if in the event that the machine is shut down improperly and the home position is not stored, we can hit that button and make any position that we have since jogged to the new home position. We also can set here our window of adjustment for travel speed, so that the values in both the auto and manual screen can be adjusted by a given percentage, in this case 10%, and with that it allows the operator some flexibility to adjust the speed. If we need to take that down to 1% or 0, then that would limit the operator abilities to adjust the speed. We can take that all the way up to 100% or 99%, which would give the operator full range of motion. We then set the weld parameters in the next screen, called weld parameters. We have buttons here for arc enable, so if we choose to run a dry cycle, we can turn that arc on or off. We can also select whether or not we want torch 1 on or off, or torch 2 on or off. We also can change our travel direction, so if in the instance we need to rotate repeatedly in a reverse direction, we can do so. Sometimes this is helpful if there is too much heat put into a part, or torch angle position requires us to rotate in a different direction. This travel speed is set in RPM. This would be the main travel speed that the operator would have the ability to adjust from. Your weld parameters should all go in here. As far as any weld schedules you come up with, your main travel speed should go in this first box. Your overlap degrees, which is the amount of over travel that the lathe will move in order to cover over the start position, and then it will cycle back to a home position. Our arc start delay is set from once we hit the start button, the torches have the ability to rest, and we give the arc on signal to initiate the arc. Our travel start delay, once the arc is on, we will wait, in this case, 0.2 of a second before we start rotation to establish our weld puddle. We have built into this machine a part support delay, and once the arc is initiated, we will continue rotation until we have a sufficient weld tack in place so that we can drop the part support and not risk dropping the part handle. This is set to 90 degrees, so once the arc is initiated, the part support will remain in the up position for 90 degrees before that part support will drop out of the way and allow the handle to rotate freely. And our final screen, mainly for diagnostics, is just a system status. It gives us an indication of what position each of the functions of the machine are currently in.
That concludes the demonstration.